Welcome to part one of our lesson on programming started services with Android messengers. After completing this part of the lesson, you'll understand how a started service, intent, and messenger can be used to design an image downloader app that displays images retrieved from a remote web server. This part of the lesson examines the app's structure and functionality, rather than looking at its implementation in detail, which we'll cover in later parts of this lesson. You'll also know how started service lifecycle operations are applied to the image downloader app. We'll be focusing initially on the started service implementation of the image downloader. This app has the same runtime behavior as the image downloader apps that are covered in MOOC 2 in this specialization. In particular, see Part 1 of the lesson Case Study, Image Downloader App in MOOC 2 for an example of how to run this app in the Android emulator and see how it downloads and displays images. You can also find the source code for this earlier version of the app, which has 3 variants, available at the link at the bottom of this slide. The image downloader apps that are covered in this module, however, are implemented differently than the ones in the previous MOOC, since they use Android services to offload the processing from the activity to a background service. You can download both of these apps at the link at the bottom of this slide. We'll begin by giving an overview of the image downloader app. This app uses a messenger to communicate from a started service back to an activity. The download activity enables a user to download and display a bitmap image via the download service. The download service, in turn, downloads and stores a bitmapped image on behalf of the download activity. It has a nested class called service handler that processes messages received from the download activity that indicate which image or images to download, store, and return. The download handler is a nested class inside of download activity. It inherits from handler and displays the images retrieved and stored by the download service. This app is complex and uses many classes and many Android components and concurrency mechanisms. We therefore analyze it from multiple design and implementation perspectives to give you a holistic view. I strongly recommend that you run the app, read the code, and watch this video carefully to understand how everything works. You can download the code from the website at the link at the bottom of this slide. We'll next describe the structure and functionality of the image downloader app. Download activity sends an intent via the start service method we've discussed before. In response to this intent, the Activity Manager service launches the download service on demand, using the activator pattern, which efficiently and transparently automates scalable on-demand activation and deactivation of services accessed by clients. The download service performs 4 main actions. These actions are nearly identical to the Android Intent Service Framework implementation that we discussed in Part 1 of our earlier lesson on concurrent programming with services. The download service first creates a service handler in the onCreateHook method, which is used to initialize the service. This service handler is associated with a single handler thread that will be used to process intents in the background. The intent processing is performed via the Hammer framework. When the onStart command is called, it goes ahead and receives the intent and then queues it inside a message in the service handler by calling the service handler's send message method via the Hammer framework. The service handler then processes this intent in the background, in a background thread, in the handler thread. The handler thread will call back the handle message hook method, which will receive the message containing the intent via the Hammer framework. The handle message method then cracks open the message, takes out the intent, looks at the URL that was designated, and goes ahead and downloads the specified image. And once the image has been downloaded and stored on the device, then the handle message method goes ahead and sends a reply back to the download activity via the messenger that was included in the intent that was sent over originally, as described in Part 3 of this lesson. Handle message will stop the service when there are no more intents to handle. This app's design is guided by a common Android concurrent service processing idiom. You can see this link for more information about idioms in general. This idiom, which is used in many other parts of Android, as well as in the Android intent service framework, offloads a task to the background thread from the user interface thread. This idiom works if and only if a service doesn't need to handle multiple requests concurrently. It handles one request concurrently at a time. The command processor pattern guides this design, as well as the design of the intent service framework. This pattern encapsulates functionality in an object that can be executed in another context, for example, at a later point in time, or in a different process or thread, as is the case here. The Hammer framework is also guided by this pattern. Let's now talk about the steps for programming the image downloader app. There are several steps involved here. These steps generalize to programming other started services beyond the one used in the image downloader app. The first step involves the activity launching the started service on demand in response to some type of user input. The started service then processes requests that are sent from the activity in the intent, and the service in this case returns a result back to the activity. That's not always the way things work, but that's the way that a lot of applications work in Android. And finally, the started service stops itself when there are no more requests to process. The service is then destroyed, and any resources it allocated are reclaimed by the Android runtime system. Let's take a look at each of these steps in turn, starting with launching a started service. A client launches a started service by calling start service, as we see here in this code snippet. In this particular example, the download activity will create an intent to launch the download service by invoking the makeIntent factory method that's part of the download service class. This factory method is passed the URL, which is where we're going to receive the image. It's also passed a download handler, which is going to be encapsulated in a messenger by the makeIntent method, and that messenger's reference is then passed as an extra to the intent with the intent. And finally, the start service method is called passing in the intent. Note, this is an asynchronous call, so it doesn't block the client while the download service runs. Let's now talk about the step involving processing requests in a started service. As we've discussed before, the Android Activity Manager service will launch the service if it's not already running, using the activator pattern as usual. Started services, much like activities, are driven by so-called inversion of control because they're a framework, as we've discussed before. The Activity Manager service is what's running behind the scenes, invoking the service lifecycle hook methods. The two methods we care about here are onCreate and onStartCommand. Download service inherits these hook methods from the service class that's provided by Android. The onCreate hook method creates and starts the handler thread and the service handler. And the handler thread works in conjunction with the service handler to download the image in the background and return the path name to the client. We'll talk about that in a second. Here's the onStart command. This is what's used to receive the intent that's sent by the activity, and then it forwards that intent encapsulated in a message to the background handler thread. And notice how onStart command returns a result, but it returns this result, which is an int, as we'll see in a moment, not to the client, but to the Android Activity Manager service. The Activity Manager service uses this return value to determine what to do with a service if its process is killed while it's running. A process would typically be killed by the Android low memory killer running in the Android Linux kernel if the memory available on the device falls below a certain threshold. Let's take a look at the return values that can be returned from onStart command. One return value is called start sticky, and this says if the service process is killed, restart it automatically, but don't pass the intent back to onStart command. Instead, pass it with a null intent so it can know it's been restarted after it was killed. Another value that can be returned is called start not sticky, which says don't restart this service automatically, but keep it stopped until it's explicitly restarted. In other words, if another component calls the start service activity to restart it. This value is intended for services that should run only while they're executing commands that are sent to them. Yet another value is called start redeliver intent, and this says restart a killed service via onStart command and deliver the intent that was delivered this time. So those are the three different types of return values that can be given back from the onStart command. A started service typically performs a single operation. In this case, the handle message method is going to do the work. And as you can see, what it will do for the image downloader app is it'll retrieve an image from the remote server and then send the path name to the downloaded image back to the client. We'll wrap up this part of the lesson by describing the third implementation step, which involves stopping a started service. Recall that a started service's lifecycle is independent of the component that launched it. Therefore, it can run in the background indefinitely, even if the component that launched it is destroyed. For example, if the download activity is shut down or killed, the download service can still continue to run. Having a service run indefinitely can chew up a lot of resources. So therefore, a service must typically be stopped when its operation or operations finish. There are several ways to stop a service. One way is to have a service stop itself by calling the stop self method. This method is carefully programmed to ensure it doesn't stop the entire service if there's still pending concurrent operations that need to be processing other intents. We'll discuss this more in part 2 of this lesson when we describe the Android concurrent service stopping idiom. Another way to have a service get stopped is for a component to call stop service explicitly. You can see here that when stop service is called by the download activity, that will cause the download service to go away. We illustrated how to do this in the music player app in part 3 of our earlier lesson on service lifecycle operations. Note that if the service isn't running, calling stop service has no effect at all. Moreover, since start service calls are not reference counted, the service will be stopped immediately, irrespective of how many times start service was called, which could be a problem. So use this particular mechanism very carefully. This concludes part 1 of our lesson on programming started services with messengers.